Hi everyone. I hope you enjoy your Christmas day. My name is Dustin. I'm a math tutor and also have a YouTube channel. It's called Dustin's Fun Math. I hope you have been enjoying my videos. I have been busy with other things lately, so I got distracted. I didn't produce that many videos the last few months. I apologize for that. But now I'm back, and let's get ready for another interesting fun math problem. So this one is about limits, and this is a little bit tricky one because it involves integration. So the first thing to do to solve this limit is we're going to substitute x with 1, right? So basically it's saying what is this limit when x approaches 1. So if I put, instead of x, if I put 1 here, so I have 1, 1 minus 1 to the power of 2, and this one is going to be 1 to the power of 3, 1. 1 plus 2 is 3. 3 times, and then the bottom one is 3 times x, which is 3 times 1 is going to be 3. And basically, the integration of 3 with whatever is in here is going to be 0. So this result is going to be 0 for integration, because when you have beginning and ending with the same number, the integral is going to go for 0. And then we have 1 over 1 minus 1, which is going to be 0. So 1 divided by 0, well, 0, so 1 minus 1 is 0, right? And then 0 to the power of 2 is 0. So 1 divided by 0 is infinity. So this is going to be infinity. And we have basically infinity times 0, which is inconclusive. We cannot have a result for that. So what we're going to do, we're going to rewrite this limit in a way that it can give us a 0 over 0 or infinity over infinity. Remember, when you have 0 over 0 or infinity over infinity, that means you can use El Hopital rule. So we're going to see what we can do with this limit. So what I can do, I can rewrite this limit as the limit when x goes to 1. So it's going to be integration of x cubic plus 2. This is 3x here. And arctangent of t, the other way to write it, we can also write it as tangent with negative 1 on top as a power. And it's not technically, it's not a power. It's not like going to say 1 over tangent of x. It represents the inverse of the tangent. All right. So it's going to be dt. And then this going to be over x minus 1 to the power of 2. So basically, I rearrange the original limit that was given to us in this form. So now what I'm going to do, I'm going to again replace the x with the 1 here. So if I do that, so if I put instead of x, I put 1, this becomes 3, this becomes 3, all right? The bottom one is going to be 1 minus 1. So we know the integration with the same beginning as the ending gives you 0. 1 minus 1 is 0. 0 to the power of 2 is 0. Now we have 0 over 0 form. And that allows us to use El Hopital rule. And just a reminder, the El Hopital rule says you take the derivative of the numerator and you take a derivative of a denominator, and then you plug in the value of x with x, and you solve it. All right. So let's do this one here. So let me make it a little bit smaller. All right. So now, what I'm gonna do, I'm gonna take an integration of the numerator, this one here. So this one, oops, sorry. This one, I'm going to write it as, so let's go flash here. So derivative of numerator, I'm going to have, you know, the formula, the fundamental theorem of calculus, is that when we take a derivative to respect of integration, and we have the beginning and ending consists of x variables, like in this case of integration, and is respect to the t. We have a t and dt here. So what you do is you take a derivative of the beginning interval, which is x cubic plus 2. So I'm going to write it here is going to be 3x squared. And then instead of t, I'm going to replace it with, so this is going to be tangent of negative 1 x cubic plus 2, right? And then you're going to say subtracting the, you take the integration of the ending of the interval of integration. So it's the derivative of 3x is 3, and then multiply by inverse of tangent. Instead of t, you're going to put 3x. All right, so that's going to be our derivative for the numerator, and the denominator is going to be 2x minus 1. That's the derivative of the denominator. So now we can plug in the x with 1. So if I do that, so I'm going to put here x equal 1. So I will get, let's make it a little bit smaller so everything can fit. So this becomes 3. I'm going to have inverse tangent of 1 to the power of 3 is 1. 1 plus 2 is 3. And then this one is going to be 3 times inverse of tangent of 3 times 1 is going to be 3. All right. And then this one is going to be 2 times 1 minus 1. So this cancel, this becomes 0, and 1 minus 1 is 0. So 0 times 2 is 0. Guess what? You got another 0 over 0. All you need to do is, now you're going to take another derivative of the numerator and denominator. So let's take the derivative of the numerator. So I'm going to use the product rule for this one here. So it's going to be 6x times inverse of tangent of x cubic plus 2. And then I write the 3x squared, and then the derivative of inverse of tangent of x cubic plus 2 is going to be 3x2, and is going to be 1 plus x cubic plus 2 to the power of 2. All right, so that's our, is this the first term right here. So it corresponds this two first terms. The next one is going to be just simply 3. So it's going to be 9, right? The derivative of 3x is 3. 3 times 3 is 9. And this is going to be 1 plus 9x squared. All right. And the derivative of the denominator is simply going to be 2. So this whole thing is going to be over 2. All right. So now what we're going to do, we are going to replace x with 1, right? You want to get the limit, right? So if I put, if I put x with, if I replace x with 1, I'm going to get 6 times inverse of tangent, and it's going to be 3. And then this is going to be x squared plus, when you replace x with 1 for x squared, it's going to be 1 to the power of 2 is just 1. So it's going to be 9 over 1 plus the x cubic here. Instead of x, you put a 1 here. It's going to be 1 to the power of 3 is going to be 1. And then 1 plus 2 is 3. So 3 to the power of 2 is 9. All right. And this is going to be minus 9 over, instead of x to the power of 2, you put 1. 1 to the power of 2 is 1. So it becomes 1 plus 9. And this whole thing is divided by 2. Let's go a little bit higher. And so these two cancel. And this 2 cancels with this 6. It gives you 3. So the final result is going to be 3 times the inverse of tangent of 3. This is the final result of the limit. I hope you enjoyed this video. Please leave me with any comments or recommendations. I love to read my comments. I really appreciate leaving me with comments. Anything that you think I can improve on my videos, that would greatly appreciate it. Thank you so much, and wish you all a wonderful new year 2026, and looking forward having another video with you guys in the future. Take care, and bye bye.